In the previous videos, we introduced the basic control modes of servo drives. Today we'll take a look at how to configure and use two communication protocols, EtherCAT and CANopen, in KincoServo Pro. In KincoServo Pro, the ECAN synchronization mode allows you to configure servo drives communicating via CANopen or EtherCAT and run them in specific operation modes, such as the interpolated position mode under CANopen, cyclic synchronous position, velocity, and torque modes under EtherCAT. For bus communication, set KEBA to 1 to enable PLC mode. The node starts automatically after power-up, and 60-60-00 immediately changes to 60-60-100, regardless of servo enable. In the ECAN panel, the software automatically switches the interface based on the connected drive type, making operation more intuitive. For CANopen communication configuration, device node IDs can be viewed and modified in the device list. After modification, click Confirm and Reboot. Set the CAN baud rate and click Write. You can configure the nodes according to your application requirement. Sync ID is required only when using synchronous transmission types from 1 to 240. It is not required in asynchronous mode. When using interpolated position mode, you must also set the ECAN sync cycle and enable the synchronization clock according to the master's sync message period. For EtherCAT, set the sync cycle and shift. Be sure that the sync clock is enabled, so all the servo drives are synchronized at the microsecond level, which is critical for multi-axis coordination, electronic gearing, and CAM applications. For safety, you can set the abort connection mode to error, so the servo drive stops automatically when a bus communication error occurs. With a network management capable master, slave parameters are typically initialized via SDO during power-up. Therefore, in most cases, manual PDO configuration using the PC software is not required. Yet you can configure PDO node ID, transmission type, and inhibit time. The interface automatically parses and displays mapped objects and corresponding values. This makes the process time efficient. In addition, SDO are used for non-real-time parameter access, such as reading or writing motor parameters and control gains during commissioning. Now, let's use CANopen asynchronous mode as a demonstration example. Confirm that the network cable is properly connected and set the drive's node ID and baud rate. Configure the corresponding communication parameters in the PLC. Then go to the PDO mapping interface and configure operation mode, control word, target velocity as inputs, set status word, and actual position as outputs. Write the PLC program and download it. Now, the PDO mapping becomes effective and is visible in the software. In synchronous mode, once communication is established, the ECAN synchronization panel automatically displays the corresponding operation mode. At this point, the PLC sends commands to the servo drive via a single Ethernet cable using the CANopen protocol. The status word, speed, and position can be monitored in real time within the software. This makes system commissioning, diagnostics, and maintenance far more intuitive and efficient.